I was expecting you to go, and you went. All right, so let's leave it like it is. And let's do what you said to do here. So this becomes a cosine.
1 minus sine.
Cosine to the what? Times cosine.
The fourth.
If
Not
it's cosine squared x squared, or cosine to the fourth.
So you're saying cosine to the fourth here, yes?
No.
Cosine to the fourth, yes?
Yes.
And that's cosine squared
Squared.
squared, yes?
Yes.
Hello, cosine squared. Go away,
Goodbye.
cosine. And make it into a.
1 minus sine squared.
Do you see this is happy? Sines with their cosine.
And then
You're gonna have to do a little algebra,
yeah, then it's
but it's gonna be integrable. All of the u's have their du there. Anybody know what I'm talking about?
Yeah.
You don't look like it. What's the next step?
square.
Yes.
Square.
So you get 1 minus.
Two sines.
I think I need a parenthesis.
Plus
Plus.
sine to the
Sine
fourth
plus
x.
sine to the fourth x. Parentheses times sine to the fourth x. Cosine x dx.
It's not exactly ready for prime time, but in a moment it will be.
Yeah.
And I want to stop and say the thinking is done here. What's the first thing you're going to be integrating? Not what's the answer. What's the first quantity you're going to be integrating?
Sine to the fourth of x
Good.
cosine x.
Stop. Oh yeah, sorry. Don't stop. Let me take that back. Pots. Pots! Okay. So he was right. So he's distributing, and then it's got to multiply by this too. Happy, huh? Sine to the fourth of the cosine? What's the second thing you're going to be integrating?
Two sines.
Minus.
Minus 2
Minus
sine
two
to
sine
the
six
fourth
x
x
cosine
cosine
x.
x.
Happy?
Yeah.
And the last thing you're going to be integrating.
Sine to the
Sine
fourth
to the
x.
Yeah.
So at this point, you know it's going to work out. So let's go back to the original question. It was an odd power. Wait, when there's an odd power, just factor 1 out. In anything with sines and cosines, evens, it's going to be easy. You're going to be able to write it in terms of the other trig function. Yes, sir?
So is that the rule, that whenever there's an odd power?
Yes.
we're gonna look-
This is a strange one. I did this one. I'm not sure if I did. Did we learn how to integrate tangent x? We know how to find the derivative of tangent x. Anyone know how we could integrate it? We can, yeah.
By parts.
Yes, but no.
As sine over cosine.
Let's see what that
Oh, that's what I meant. That's what I meant by parts.
That's not parts. Because that, if you do it carefully, is a happy integral. Do you see why it's happy?
Oh,
Do
yeah.
you see why it's happy?
Yes.
Mhm.
That only happens if you is hungry. If you is happy.
Cosine.
So essentially, there's a u here, and what's up here?
D.
Close.
Negative.
Yes.
How can you do it the other way around?
Because the derivative sine x is not dx over cosine x. It's not. That's why. So again, there's a u down here, and what's up here?
Negative.
So integrate. What do you get?
1 over cosine squared.
No.
No.
You're integrating. Forget the
One
name.
over yeah,
du over u.
which is 1 over ln
So it's ln u.
Yes.
ln u. I have the
Yes.
value.
Yes. We did this.
Yeah.
So what are we getting?
Negative.
Negative ln of.
Negative ln of absolute.
Of cosine.
Alright. Of cosine x.
Plus
Plus c.
So I want to present something right here that's new. The integral of secant x is the dx. This is going to be one of those things I'm going to ask you to memorize. It's the ln of absolute value of secant x plus tangent x plus C. I don't have a derivation for why it is, but I'm happy to work with you and show you that it's correct. How could we show that it's correct, or whether or not it's correct?
Keep the derivative of ln secant.
Let's try it. So let's put it over here. What should we get if it's correct?
Secant.
Let's see what we get. So the derivative ln of derivative C is 0. Derivative ln of stuff is.
Whatever stuff.
Okay, we write the stuff here. I love that you're saying it that way. And so times what?
Secant.
Which is?
Secant x tan x.
Yeah.
Plus secant squared x.
Oops. How many understand so far what we did? Okay, do you hear the numerator? How?
Factor secant.
And if you factor out a secant x, what's left?
10x plus
Perfectly said.
So cool.
Okay,
So
so
cool.
in fact, it's correct.
Wow, those are really easy.
Yeah. I need for you to memorize this. And similarly,
More.
the integral of cosecant x dx.
Plus secant x.
Actually, it's the negative, as one might expect, ln of,
So secant x plus
yes,
cotangent.
heck yeah. Oh, let's see.
Plus c.
So these are gonna come up, not very often, but sometimes they'll come up. And you'll end up having to integrate secant or cosecant, and now you know how to do it. We did tangent together, cotangent is very similar, yeah?
Yes.
As Russell pointed out, for cotangent though, we'd make it cosine over sine, yeah?
Use some.
It'd be easy to do. Okay. Max, did you just have a question? I thought you had, no, okay. I only have a couple more to go. And anything that I show you for tangent is obviously similar for cotangent. So let's go to tangent cube x. No, I should do this first. Tangent squared x dx isn't happy, but it could be happy. So once again, some of you have a trig deficiency. Vitamin E, get the liquid form of it, put it on your hands, rub it on your temples. Write trig on the bottle. Trig. Then
Sine squared of x over cosine.
it doesn't help you, you know.
Or,
Yeah.
Secant squared of x minus 1.
Actually, you memorized it in this form, but it's obviously the same as what you just said. One is so easy to integrate, and secant squared is easy to integrate. What do you got?
X
X
plus 10
plus 10.
So again,
Plus
you're
eight.
seeing this and your brain isn't seeing this, that's not good. And I don't want you to stress it. I don't want you to simply review it. That's not good enough. I don't want you to be familiar with the trig. I've said this to you several times. I said it to you last year when I retaught the trig to you. I'm never going to be teaching it again. You absolutely have to know it. If you don't, you're going to be done, toast on these kind of questions. You're going to be working on it, and you're not going to know what to do. Simply, not the calculus, because you don't know the trig. So you just have to know. So let's look at this question now. Let's see if any idea pops into your head. There's no identity for that. Let's see what we could do. I'll give you a hint, something similar to what we did with sine, odd powers of sine or cosine. We're going to do here as well. Got it?
Well, I think I know what to do.
Can do it, can do it. Part of what I'm asking of you is to be sort of a mathematical chess player. If you're playing chess, you're thinking not of the move you're gonna make, but the next 3 moves. And that's what you need to be able to do. And you have to have all that trig to be able to think ahead. Will this work? Let me decide. No, let me try something else. Will this work? Yeah, I think this is gonna work out. I'll try it. That's how your brain's gonna operate for this. Get it?
Yeah.
I think so.
So close.
So close. Okay. So having said what I said, it's obvious you're going to do what next?
You do secant squared x plus 1, and then times, I did sine over cosine.
So I think you went too far. First step, he factored out a tangent x. He has got tangent x times tangent squared x. This was very good, this move. Writing this as sine x over cosine x is certainly true, but certainly useless. This has nothing to do with this. So you're using an extra identity which doesn't count. This is what I mean. Please listen to the thinking part here. This is what I mean about chess analogy. If I did this, I would have integrating tangent x.
Yeah, we know that.
Can I?
Yes.
I just did. And I would have tangent x secant squared x. Can I do that?
With the
Yes.
parts,
No.
No.
no, there's no.
So now you're missing a calculus concept. This is the derivative of tangent x. This is a u du. You don't know what I'm talking about.
Okay.
This is tangent x, I'm distributing,
Yes.
plus tangent x
Secant.
secant squared x dx. U du.
I was stuck seeing
Oh,
secant.
secant, tan secant, oh, okay.
I thought you said no.
Pardon me?
I thought you said
So I
no.
said yes,
I said no to what?
You said
that we
no.
couldn't
Uh,
do it.
You asked if we could do it.
You said yes.
And you said no.
I didn't say no. Your brain should have said, this is a step ahead. Can I integrate tangent x? The answer was yes. And can I integrate tangent x secant squared? And you all looked at me like I was speaking in Martian. You didn't recognize that tangent secant squared is like a sine cosine x. So happy. That's the derivative of that, Bruce. So we have a method here. If you realize you have a deficiency, fix it immediately. Don't say, all right, I'll study it before the test. It won't work. Fix it today. I mean it. Soon in any class, any lesson that I teach, if you realize I have a weakness, these other people know this stuff about it, and I don't know it, I gotta fix it today. I gotta come in tomorrow and know how to do that. Because everybody else knows, how come I don't know? So if I'm pointing it out to you, please take it to heart. I wanna do one more question, and then I'll get to your other homework questions if you have. This topic is also included on the test on Tuesday, double period test. We did odd powers of sine and cosine, we did and even, we did odd powers of tangent, also for cotangent, and now we'd like to look at even powers for tangent and also for cotangent. Anyone have an idea? Yeah, I wouldn't expect you to actually know, but at least an idea, yeah.
1 plus secant squared x, 1 squared.
Okay, it's certainly equal to that. No, it's 1 minus secant squared. It's tangent squared plus 1 that equals secant squared.
Well, then are all those other ones on the?
1, oh, it is minus.
Yeah.
Remember tangent squared plus 1 equals secant squared?
Secant squared of x minus 1.
Sorry.